Bonding ground and neutral together creates a path for electricity to flow unintendedly, increasing the risk of shocks, fires, and equipment damage. Combining multiple circuits in one conduit can overload the wiring and cause overheating, which can lead to house fires. Using a number 8 wire for a neutral carrying multiple 20-amp circuits is insufficient and can cause overheating and voltage drop. Article 250 of the National Electrical Code prohibits bonding the ground and neutral at the service panel or anywhere else in the electrical system. Article 300 of the National Electrical Code requires circuits to be separated by barriers within a conduit to prevent overcurrent and fire hazards. Article 310 of the National Electrical Code specifies the minimum wire gauge required for various loads and circuit lengths. The electrical system is unsafe and poses a danger to occupants and property. Insurance companies may refuse to cover damages caused by faulty electrical work. The customer may be held liable for any accidents or injuries resulting from the unlicensed work. It is important to explain the safety concerns and code violations in detail, using simple and understandable language. Emphasize the potential risks of using an unlicensed electrician and remind them of the importance of hiring qualified professionals. Recommend immediate repairs by a licensed electrician to ensure the safety of their home and family. When evaluating electrical work, especially when performed by unlicensed individuals, several key areas require close inspection to ensure safety and compliance with the National Electrical Code. Firstly, verify the grounding and bonding system. The neutral and ground should only be bonded at the service entrance. Bonding them elsewhere creates parallel paths for neutral current, leading to potential shocks and equipment malfunctions. Check for proper grounding electrode conductor size and connections to metallic water pipes and ground rods. Secondly, assess circuit loading and conductor sizing. Ensure that each circuit is not overloaded beyond its ampacity. Verify that the wire gauge is appropriate for the circuit's ampacity and length, consulting National Electrical Code Table 310.15b16 for ampacity ratings. Pay attention to conductor bundling in conduits, as this reduces ampacity. Thirdly, inspect wiring methods and protection. Examine the type of wiring used, ensuring it is suitable for the environment. Check for physical damage to conductors, proper support and protection, and correct box fill. Verify that all junction boxes are accessible and properly covered. Fourthly, review overcurrent protection. Confirm that the circuit breakers or fuses are correctly sized for the conductors they protect. Ensure that all overcurrent devices are functioning correctly and are not tampered with. Look for signs of overheating or previous failures. Fifthly, investigate arc fault circuit interrupters and ground fault circuit interrupters protection. Arc fault circuit interrupters are required in many areas to protect against arc faults, which can cause fires. Ground fault circuit interrupters are required in wet locations and other areas to protect against electrical shock. Test these devices to ensure they are functioning correctly. Sixthly, check for proper labeling and documentation. Verify that the electrical panel is properly labeled, indicating the circuits and their corresponding loads. Look for any missing or incorrect information. Ensure that there is a readily available diagram of the electrical system. Seventhly, examine equipment grounding. Verify that all electrical equipment, such as appliances and machinery, is properly grounded. Check for continuity between the equipment grounding conductor and the grounding electrode system. Eighthly, assess voltage drop. Excessive voltage drop can cause equipment malfunction and overheating. Calculate the voltage drop for each circuit, ensuring it is within acceptable limits. Ninthly, inspect for any signs of overheating or damage. Look for discoloration, melted insulation, or other signs of overheating on conductors, devices, and equipment. Check for any physical damage to the electrical system. Tenthly, verify compliance with local codes and regulations. Contact the local electrical inspector to determine if the work meets all applicable codes and regulations. Obtain the necessary permits and inspections. In addition to these specific checks, be aware of common red flags that indicate substandard electrical work. These include loose connections, exposed wiring, incorrect polarity, and the use of unapproved materials. When correcting unsafe electrical conditions, always follow proper safety procedures. De-energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and eye protection. If you are not qualified to perform electrical work, hire a licensed electrician. It is also important to understand the implications of National Electrical Code violations. These violations can result in fines, penalties, and legal liability. They can also increase the risk of electrical shock, fire, and equipment damage. Insurance companies may deny coverage for losses resulting from code violations. Here is more information to help guide the evaluation of an electrical panel. Firstly, identifying the main service disconnect. Locate the main breaker or disconnect switch that shuts off all power to the panel. This is usually at the top of the panel. Verify that it is clearly labeled and easily accessible. Secondly, checking the panel labeling. Ensure that all circuits are clearly and accurately labeled. The labels should correspond to the actual loads they serve. Replace any missing or incorrect labels. Thirdly, inspecting for proper grounding. Confirm that the grounding electrode conductor is properly connected to the grounding electrode system. This includes connections to metallic water pipes, ground rods, and other grounding electrodes. Verify that the grounding electrode conductor is sized correctly. Fourthly, examining the neutral bus. Ensure that the neutral bus is properly isolated from the panel enclosure except at the service entrance. Check for any loose or damaged connections. Fifthly, checking the bonding connections. Verify that all metallic components of the electrical system, such as conduits and enclosures, are properly bonded to the grounding system. This ensures that they are at the same electrical potential. Sixthly, inspecting for proper wire terminations. Check that all wires are properly terminated at the circuit breakers, neutral bus, and grounding bus. Ensure that the connections are tight and secure. Look for any signs of overheating or corrosion. Seventhly, verifying circuit breaker sizes. Confirm that the circuit breakers are correctly sized for the conductors they protect. The breaker size should not exceed the ampacity of the smallest conductor in the circuit. Eighthly, assessing the available breaker spaces. Determine if there are sufficient breaker spaces available for future expansion. If the panel is full, consider installing a larger panel or a sub-panel. Ninthly, checking for proper wire management. Ensure that the wires are neatly organized and properly routed within the panel. This makes it easier to troubleshoot and maintain the system. Tenthly, looking for any signs of damage. Inspect the panel for any signs of damage, such as rust, corrosion, or physical damage. Replace any damaged components. Another point to consider is regarding wiring and conduits. When multiple circuits are run in the same conduit, the ampacity of the conductors must be derated according to National Electrical Code Table 310.15 Kern. This derating is necessary to prevent overheating. Ensure that the conductors are properly derated based on the number of current-carrying conductors in the conduit. Neutral conductors are considered current-carrying conductors if they carry significant current. In a three-wire circuit consisting of two-phase conductors and a neutral, the neutral carries approximately the same current as the phase conductors. In a four-wire circuit consisting of three-phase conductors and a neutral, the neutral carries only the unbalanced current. Grounding conductors are generally not considered current-carrying conductors. However, if they carry current, they must be considered current-carrying conductors for derating purposes. When multiple circuits are run in the same conduit, the conductors must be grouped together. This helps to prevent inductive heating. The conductors can be grouped together using cable ties or other means. The conductors must also be identified. This can be done by color-coding the conductors or by using labels. When running multiple circuits in the same conduit, it is important to follow the National Electrical Code requirements. This will help to ensure that the electrical system is safe and reliable. Another consideration is aluminum wiring. Older homes may have aluminum wiring, which can be a fire hazard if not properly maintained. Aluminum wiring expands and contracts more than copper wiring, which can cause connections to loosen over time. Loose connections can cause overheating and fires. If you have aluminum wiring, have it inspected by a qualified electrician. The electrician can install special connectors that are designed for use with aluminum wiring. These connectors will help to prevent the connections from loosening. The electrician can also apply an antioxidant compound to the connections, which will help to prevent corrosion. Corrosion can also cause connections to loosen. Another aspect to consider, especially in older homes, is knob and tube wiring. Knob and tube wiring is an outdated wiring method that is no longer permitted in new construction. Knob and tube wiring consists of single insulated conductors that are supported by porcelain knobs and tubes. The insulation on knob and tube wiring can deteriorate over time, which can create a fire hazard. If you have knob and tube wiring, have it inspected by a qualified electrician. The electrician can recommend whether to replace the wiring or to take other measures to improve safety. It is vital to remember that electrical work can be dangerous. If you are not qualified to perform electrical work, hire a licensed electrician. A licensed electrician has the training and experience to perform electrical work safely and correctly. Hiring a licensed electrician will help to ensure that your electrical system is safe and reliable. They will also be able to identify any potential hazards and recommend solutions. Electrical safety is not just about preventing electrical shock. It is also about preventing fires. Electrical fires are a leading cause of property damage and injury. By following proper electrical safety practices, you can help to protect your home and family from electrical fires. Moreover, consider surge protection. Surge protection devices can protect your electronic equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, and other events. Surge protection devices are available in a variety of types, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect all of the electrical equipment in the house. Point-of-view surge protectors are plugged into outlets and protect the equipment that is plugged into them. It is always a good idea to have a qualified electrician inspect your electrical system on a regular basis. An electrical inspection can identify potential problems before they cause damage or injury. Electrical inspections are especially important if you live in an older home or if you have recently purchased a home. They can also be useful if you are planning to add electrical equipment or make other changes to your electrical system. If you are planning to add electrical equipment or make other changes to your electrical system, it is important to obtain the necessary permits. Permits are required for many types of electrical work. Obtaining permits will help to ensure that the work is done safely and correctly. It will also help to protect your property from damage. When obtaining permits, be sure to provide accurate information about the work that you are planning to do. This will help the building inspector to determine whether the work meets all applicable codes and regulations. Ensure the panel cover is securely in place. The panel cover prevents accidental contact with live electrical components. Replace any missing or damaged screws. Check that all knockouts are properly filled. Knockouts are the openings in the panel that are used to run wires into the panel. If a knockout is not properly filled, it can create a fire hazard. The proper way to fill a knockout is with a knockout seal. A knockout seal is a metal or plastic disc that is inserted into the knockout. Ensure that the panel is properly ventilated. The panel should be located in a well-ventilated area to prevent overheating. Overheating can damage the electrical components in the panel and create a fire hazard. Check that the panel is not located in a damp or wet location. Water can damage the electrical components in the panel and create a shock hazard. If the panel is located in a damp or wet location, take steps to protect it from water. This could include installing a waterproof enclosure around the panel. Also, check that the panel is not located in a hazardous location. Hazardous locations are areas where there is a risk of explosion or fire. These locations include areas where flammable liquids, gases, or vapors are present. If the panel is located in a hazardous location, it must be specially designed and installed to prevent explosions and fires. Remember to always be aware of the dangers of electricity. Electricity can be deadly. If you are not qualified to work with electricity, hire a licensed electrician. A licensed electrician has the training and experience to perform electrical work safely and correctly. Hiring a licensed electrician will help to ensure that your electrical system is safe and reliable.